So in our final video on chemical bonding, I think we're up to the 6th episode, we are going to look at continuous covalent bonds. Now, continuous covalent bonds are like covalent bonds in that they involve shared pairs of electrons, but they also involve a continuous lattice like what we see in metals and in ionic compounds. And we're going to see a bit of a combination of the properties of those two things due to that combination of the structures. So typically we get a lot of continuous covalent compounds involving compounds that contain carbon, like diamond and graphite, and also compounds involving silicon. And that's because they're both in group 4, so that means they want to share 4 electrons. So 4 electrons is a lot of electrons to share, so we could think of that they like to share, so they can share with lots of atoms, and they can form these big networks of covalent bonds. So this first example here is diamond, which is basically made up of a whole series of carbon atoms, and all of those carbon atoms are sharing their 4 electrons with neighbouring carbon atoms. We've drawn that there in 3 dimensions. That's why it looks a little bit different to normal, but you can just think of all those carbons neighbouring up to other carbons and all sharing electrons. So each carbon shares with 4 other carbons and shares 1 electron. And we just get this continuous network of covalent bonds. We get a similar thing in graphite, except in graphite they form these layers. Now you have been making use of these layers in graphite for lots of years without even maybe using it, because a lead pencil doesn't actually contain lead. A lead pencil contains graphite. And when you write with a lead pencil, you're basically stripping off all these layers of continuously bonded carbon atoms, and you're stripping them onto the paper, and that's what's leaving the mark on the paper as each of these layers comes off. Another common continuous covalent network involves silicon in red and oxygen here in blue, and they bond together in this continuous structure, and that forms the basis of glass, but it also forms the basis of lots and lots of minerals like quartz and beach sand, which is found in beach sand, and a lot of other minerals that you find in rocks. So once again, these are covalent bonds, but they don't just contain a small number of atoms. They contain large networks of either carbon atoms, in the case of diamond and graphite, or oxygen and silicon atoms, in the case of silicon dioxide or glass. Now, these, because of their large networks, they have some particular properties. They tend to have higher melting points, because there's a large network of strong primary covalent bonds that takes a lot of energy to break. So these covalent bonds are all very, very strong, and they go on and on and on in a lattice. So that basically makes the lattice very hard to break apart and makes it very hard to turn these things from solids into liquids. Generally, they will not conduct electricity as there are no charged particles. It's not like in the metals where we have those electrons free to move through the structure. In this case here, we have shared pairs of electrons. We don't have positive and negative charges. We don't have free electrons. So there's not normally any charges that are free to move through the structure. Now, graphite is an exception. Graphite here can conduct electricity. It's quite a complex mechanism that you don't need to know about this year. You don't even need to know about for year 12. If you ever go on and do some university chemistry or physics, you may learn about what's actually special about this structure of why it conducts electricity. If you're interested, go away and research it for yourself, but you don't need to know it. But just making you aware it's an exception, so if one day you electrocute yourself with your lead in your lead pencil, you don't blame me, because that is actually a conductor and electricity can move through it. They also tend to be very hard. Diamond is basically the hardest substance we know about, and that is, again, due to the fact that there's a lattice of strong primary covalent bonds. So these bonds are all locked in structure. They're very strong bonds. It's very hard to basically deform those bonds or even to break those bonds. So things like diamond and even glass, and things like quartz, all tend to be particularly hard. Graphite is a little bit different in that because these layers can peel off, it tends to have that softer structure. But it's still continuous covalent. It's just a whole heap of continuously covalently bonded layers all stacked on top of each other. So I don't need a huge amount of detail on the continuous covalent compounds, but just need to make you aware of what they are and how they are different from the metallic, ionic, and the small molecular covalent compounds that we have seen in the previous videos. Thank you.